All right, next one we're going to look at is a Maclaurin series for sine of x. So again, remember that when we're doing this, our general Taylor series comes out to be that we're doing f to some derivative here because it's a Maclaurin one, rather than some number like 6 here, we're doing it at 0. Maclaurin is always around 0. And then it's going to be the n factorial times x to the n power. So if we're doing sine of n, we want to create a table over here around sine of n. So we're going to do all the derivatives here, and then we're going to figure out what all those derivatives are going to be at 0. So if we're doing sine of x, our function here would be just sine of x. What is sine of 0? Well, if you go on your calculator, you remember unit circle, we know that's the y value. The y value at 0 is going to be 0. So that's that one. Now let's find our first derivative here. Derivative of sine is cosine. So now what is this at 0? Well, cosine of 0 is 1, because that on the unit circle we're talking about this point right here, which would be the point 1, 0, and cosine's the x value. All right, second derivative. Derivative of cosine is negative sine. So what is that now at 0? So if you do a derivative of that, you should get 0. Next one. Third derivative is derivative of negative sine would be negative cosine. And that third derivative at 0 would be negative 1. Let's do one more. The fourth derivative of this would be back to positive sine now. And we know from before that if we get positive sine, this is going to come out to be 0. Not 1, 0. Now after this, everything, all the next derivatives should cycle through because we got sine and we're back to sine here. So the next value should be, in this list should be 1, then 0, then negative 1, back to 0 again, and so on going down here. It's going to be cyclical. So what does this look like now if we write this out? Well, the first term in this would be we'd be putting 0 in here, so it'd be f to the 0, which is just our function evaluated at 0, which is going to come out to be 0 over 0 factorial times x to the 0. The next term would be the first derivative at 0, which comes out to be 1 over 1 factorial times x to the first power. The next one is going to be the second derivative at 0, which is 0 over 2 factorial x squared. The next one would be the third derivative at 0, so negative 1 over 3 factorial x to the third. Let's go a couple more. Let's go 2 more here. The next one would be the next derivative at 0, so 0 over 4 factorial x to the fourth. And let's do this last one. So the next one would be the fifth derivative at 0, which is 1 over 5 factorial x to the fifth. And this would continue on in the same pattern. I'm going to simplify some of these. So the first one, if we have a 0 here, 0 times anything is just going to make all that 0. So that 0, we don't even need to write anything. The next one, 1 over 1 factorial. 1 factorial is 1. 1 divided by 1 is 1. So we got 1 times x to the first, which all just could be written as x. So that's the first one. The next one has a 0 in this one as well. So all this times 0 is just going to be 0. I'm not going to write anything for that. The next one here would be, it's going to be negative. So I'm going to put minus. And then it looks like it's x to the third over 3 factorial is what remains there. The next one's 0 again. I'm not going to write anything. The next one becomes 1 plus x to the fifth over 5 factorial. The next one would be a 0 one again. If you were to find the next one, you would get that it would come out to be negative, and it would be x to the 7th over 7 factorial. So hopefully now you can kind of see that pattern. How could we write out this one now as a series? So basically what we want to write is, what is sine x going to be equal to as a series? What's that general pattern? Well, some things you notice here. We only have the odd powers here. This is like x to the first. So we only have the odd powers. The even powers are all 0. And the factorial underneath matches. One other thing to notice is that we go from positive to negative to positive. So this is an alternating series as well. So let's start with that alternating part. This is an alternating series, so we're going to have one of these negative ones in there. And we want the first one to be positive. So when we plug in that first term, we want it to come out to be positive. Let's start with 0 here. So then if we would just put an n, that first one should come out to be positive, because negative 1 to the 0 power is positive 1. And then the next one should be negative, and so on. All right, so now how do we write this so that we only get the odd powers here to come out now? So we want to write this in a way that's going to only give us the odd ones. So if we had, we definitely need an x in there. So how do we write this exponent in terms of n so that it only comes out? Well, if we just did only n, we would get 0, then 1, then 2, then 3, but we don't want the even ones. So if we just want every other one, we could do something like times it by 2. Timesing it by 2 then would give you just every other one. So now if you put in 0, it would be 0. If you put in 1, you get 2. If you put in 2, you get 4. So now it's skipping, but we're only getting the even ones. So if we want the odd ones, what we can do is add 1 to that. So let's test it now. If you put in 0, 2 times 0, 0, plus 1 would be 1, so we get 1. If we put in 1, 2 times 1 is 2, plus 1 is 3. So yeah, now we would get the odd ones. And that same thing now should work with our factorial. So if we put in 2n plus 1 factorial, that should also give us the same thing underneath. So that is the series right there for sine of n, or sine of x. So generalizing that, you can see here, this is another one you should know for the AP test, how to write out sine of x. So it's the odd powers alternating, starting with the first one that is positive. Let's take a look on that Desmos one again to kind of so you can visually see this. So if we go to the Desmos one, let's change this function to sine of x. So there's the graph of sine. You've seen this blue curve before. Let's go through the progressions here. So this is at 0. This would just be the very first term of this. So that's just going back here, that would just be this 0, 1 that came out to be nothing. So it's just a horizontal line through 0. If we go to the next one, there's our tangent line. That would be just the graph of x. Notice it didn't change at all when I went here, because remember that next one, that the even terms aren't going to change. It's just when we get to these odd ones. So there's the next one. Okay, got closer. Definitely that red line looks more like the blue curve now, especially around 0. This one's not going to change it, but now we should see a change on the next one. Okay, see how it's approximating the blue line more? No change. Here we're going to see a change again. Yep, starting to look more like it. No change. Here's another change. So you can see that red graph starts, the approximation starts looking more and more like the graph of sine. And if you did this out to infinity, it would match the blue curve.